on this computer. All right, so we are doing lesson solving multi-step equations notes. I can solve equations that involve multiple steps. We have solve linear equations with rational number coefficients, including equations whose solutions require expanding expressions using the distributive property and collecting like terms. Okay, so we want to just have a refresher from pre-algebra about what like terms are. Like terms are terms that have the same variables and exponents. Okay, terms that have the same variables and exponents. So for example, 3 and -5, 6x and 7x, -2x squared and positive 12x squared, 9a and -4a. So notice that they are the same variable to the exact same power. So x to the first power, x to the first power, x to the second power, x to the second power, a to the first, a to the first. Constant, which is a number, and another constant. All right, so when we are working with equations and solving equations, we want to make sure that before we start the solving process, that we simplify the expression first, and then we will use the order of operations in reverse to solve for unknowns. So when we simplify, we are going to use by combining like terms. So combining like terms, and you can abbreviate that CLT if you wish. So simplifying these expressions entails combining like terms into one term. Always look at the symbol in front of the term to see if it is positive or negative. So addition is positive, subtraction is negative. And remember, we're using those interchangeably when we're looking at expressions and equations in algebra. So when I look at number 1, I see 3c, and I know that's positive, and I see this c, I know that's also positive. When there is not a written coefficient in front of the variable, it's an understood 1. So that's just 1c. So here we have a 3c, and here we have a c. So that is 4c. And then we have -2. That's a constant. That's just a number. So -2. That's our answer. We combined the like terms. We have 4c minus 2. Number 2, we have -9g, and we have +3g. Those are like terms. So 9 negatives. 3 positives. What did we have more of? More negatives or more positives? We have more negatives, so that'll be negative. And then we have -23 and -4. That's -27. So we have, -9g plus 3g is -6g. And then -23 minus 4 is -27. So -6g minus 27. And that's our answer because it's an expression. We cannot add g's to numbers. They are not like terms. We cannot add c's to numbers. They are not like terms. We can only add g's to other g's. We can only add c's to other c's. Okay, number 3. Okay, we have 4 terms. 1, 2, 3, 4. We have a term with an a. We have 2 terms with b, and then we have a constant. Okay, so I can only add a's with other a's. That's a positive for a. Remember that that plus also starts as a positive. So this is a positive for a. And then we move on to our b. We have 18b plus 5b, which will give us 23b. They're both positive. Positives plus positives equals even more positives, so plus 23b. And then -12, that's a constant. Okay, so the simplified expression is 4a plus 23b minus 12. That's our answer. We can't evaluate that because we don't know what a equals and we don't know what b equals. Okay, next, number 4, we have 5x squared and we have -9x squared. Okay, so we're combining integers here. First of all, do we have more positives or more negatives? We have more negatives, so that means that the sum is going to be negative. How many more negatives than positives are there? Well, we have 9 negatives and we have 5 positives, so there are 4 more negatives. So -4, and then the variable is x squared. I can only add x squared to other x squareds. I can't add an x squared to an x. This is a 2-dimensional thing, like a sheet of paper is 2-dimensional, okay? This is a one-dimensional thing, like a length of something. So a string might be, 5 inches long. So I cannot add something that's two-dimensional to something that's one-dimensional. I can't add an x squared to an x. They are unlike terms. Okay, then we have here negative 7x. I don't have any other terms with just x, so that's minus 7x. And then I have a positive 6 and a positive 19. Okay, so 19 plus 6 is 25. When we write expressions, okay, so right now we only have one variable, okay, x. Okay, we have two different powers of x, x squared and x to the first. When we write variables, we always write them in descending, so that's going from highest to lowest. We always write them in descending powers, okay? So this is x to the second power, x squared will always go before x. And we do that in math because we like to have a standard notation. We want to know that there's one correct answer, not, oh, well, I wrote it as negative 4x squared minus 7x, well, you wrote it as negative 7x minus 4x squared. Those are both correct. No, in math and science, we want to be precise. We want to have one understood way that we write. So our mathematical language, the standard practices, we write them in descending order of the powers. So x squared will be first and x will be second. And if you have those reversed, that's incorrect. Okay, so we'll always be working in the standard accepted notation for algebra, because we don't want to say, oh, it's fine. And then when you get to algebra 2, you have so many new rules and things. So we are going to learn it correctly right from the beginning. So you do need to write them in descending order of the powers in order to get the answer correct. All right, so then now that we've had some practice with combining like terms, okay, so now we're going to take the two skills that we've learned most recently, so the combining like terms from today and then solving equations from last week, and we're going to combine them together. So when we're solving equations, the first thing we want to do is we want to get that equation as simplified as we can get it by combining like terms. Then once we have it simplified, then we will use the order of operations in reverse to solve. So we'll always simplify first, then we will solve, okay? So simplify and then solve, okay? Always simplify, make it as straightforward as it can be, then you use your order of operations in reverse. Otherwise, you're going to have way too many steps in solving your equation, okay? Our notes phrase it a little bit more specifically. Number 1, combine all like terms. Number 2, solve the 1 or 2 step equation. Okay, so next, we have negative 4x plus 4 plus 5x equals negative 5. So we need to combine like terms first. We have negative 4x and positive 5x. So we combine like terms here, negative 4x plus 5x, that's going to give us x. And then we have plus 4, and then bring down the equals negative 5. So that was simplified. We combined our like terms first. Now that it's simplified, the next step is to solve, and we solve by using the order of operations in reverse. So remember that from, actually it was earlier this week, you do the order of operations backwards. So we will subtract 4 from each side, which gives you x equals negative 9. Okay, number 2, we're going to combine like terms first. We have negative 6x and minus x, which is negative 7x. Bring down the plus 3 equals negative 32. Plus 3 equals negative 32. Okay, so we've combined like terms, and then there on this side, and if there were like terms to combine on the right side, we would have done that as well. So the equation is simplified. Now we can do our solving order of operations in reverse. Okay, so subtract 3 from each side, that gives you negative 7x equals negative 35, and then divide each side by negative 7. So you got x equals 5. Then number 3, we're going to combine like terms on the right-hand side. We have 6x plus 2x. 6x plus 2x is 8x. Bring down the minus 9, bring down the equals negative 1. Okay, now there are no more like terms to combine on either side. Okay, so we add 9 to each side. This gives us 8 equals 8x, and then divide each side by 8 to get x equals 1. And then we can do a mental math check step with those equations. Okay, page 2. Okay, when we're working with the distributive property, we multiply the term outside the parentheses with all the terms that are inside of the parentheses. Multiply the term that is outside of the parentheses by all of the terms that are inside of the parentheses. Okay, so here, if I have A times the quantity B plus C, I will distribute this A and I multiply everything that's inside the parentheses by A, because remember, these parentheses tell us to multiply. So A times B would give us AB, and then A times C would give us AC. So we end up with AB plus AC, and now we don't have parentheses, and now we can solve. Okay, and then here's an alternative with a example with a subtraction. So if I'm multiplying A over everything inside the parentheses, A times B is AB, A times minus C or A times negative C is minus AC. All right, so let's do some examples here. Expand these expressions using the distributive property. So we are going to be distributing a 3. It's a positive 3, okay? If it were negative, we would be multiplying everything inside the parentheses by negative 3, but it's positive, so everything gets multiplied by positive 3. 3 times x is 3x, and 3 times minus 5 is minus 15. So we end up with 3x minus 15. Now we don't have parentheses, and that's going to help us when we're solving solving equations. Number 2, we have a 6 outside of the parentheses. Okay, 6 times 2x is 12x. 6 times 7 is 42. So we just have 12x plus 42. Then number 3, we need to be more careful because we have a negative. And the most common mistake that kids make is they multiply the first number in the parentheses by a negative 2, and they multiply the second number in the parentheses by a positive 2. That's a very, very common error. So make sure that whatever you have out here, everything inside of the parentheses gets multiplied by that same value. Okay, so we would do negative 2 times positive 4x, that's negative 8x, and negative 2 times negative 5 is positive 10. The number one mistake is that people will multiply the 4x by a negative 2, but they'll multiply the negative 5 by a positive 2. Remember, everything gets multiplied by the negative 2. Okay, so I find that it's helpful if students circle that value and then draw the arrows, which remind you that everything gets multiplied by that negative 2. Okay, so next we're looking at solving equations using the distributive property. Solve each equation using the distributive property first, and then solving the 1 or 2 step equation. So for number 1, we have 4 times the quantity x minus 11 equals 24. So we are going to distribute this 4 over the quantity x minus 11. So 4 times x is 4x. 4 times minus 11 or 4 times negative 11 is minus 44. And then bring down the equals 24. So then we have negative 4x minus 44 equals 24. So now it's simplified as it can be. Now we use our order of operations in reverse to solve. So that's a 2-step equation. We're using PEMDAS in reverse. Okay, so we are going to add 44 to each side. That gives us 4x. Then negative 44 plus 44 is 0. So we are allowed to slash that out because 4x plus 0 would just be 4x. Bring down the equal sign. 24 plus 44 is 68. Then we divide each side by 4. 4 divided by 4 is 1. 68 divided by 4 is 17. So x equals 17. Okay, and a quick way of dividing by 4 is to divide by 2 and divide by 2 again. Okay, so that's a little helpful mental math tip for you. A quick way to divide by 4 is divide by 2 and then divide that by 2. Okay, so dividing by 2 twice is the same as dividing by 4. Number 2, we have 3. And we're distributing that over the quantity negative 3x minus 4. So 3 times negative 3x is negative 9x. And also back to this, you should not be using a calculator on any of the lessons that we're doing right now. When you have your PSAT test and your SAT test, these are all non-calculator questions. So you want to go all through Algebra 2 or Algebra 1 and Algebra 2, doing as much arithmetic in your head as you can. Okay, do not become dependent on your calculator, because when you get to that non-calculator section of your SAT, it's really going to drag you down if you have to type in something like this in your calculator, because you have to put down your pencil, pick up your calculator, type it in, hit enter, pick your pencil back up, write it down, fill in the bubble. Okay, whereas if you can do it in your head, it's divide by 2, 17, fill in the circle, next question. So while this, it is a little bit more time consuming to practice that arithmetic in your head now, by getting that memorized, it's going to really pay off big dividends for you when you're taking your college tests. Okay, so practice that arithmetic. Do not grab your calculator. Force yourself to do these without a calculator. Okay, it's for your own good. It's like eating your veggies. Okay, all right, so then we were distributing this 3 here. So 3 times negative 3x is negative 9x. 3 times negative 4 is minus 12, and then equals 15. Then we're going to add 12 to each side. This gives us negative 9x. Negative 12 plus 12 is 0. Bring down the equals, 27. Then we divide each side by negative 9. This gives us x equals negative 3. Okay, number 3, we're distributing a negative. So we want to be really careful to make sure that we remember that negative with the 4. So again, I like you to circle that and then draw those arrows for multiplication. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. Bring down the equals 12. And then we add 12 to each side. Oops, no we don't. We subtract 12 from each side. Sorry. And then also, so I realized my mistake here because I was like, wait a minute, 12 plus 12 is going to give me 24. Okay, so I'm not looking at that automaticity where I'm just slashing through when I see 2 numbers that look alike. I'm always doing that math in my head so that if I make any mistakes along the way, I check it. So if I would have just been in the habit of, oh, slash through because they're both 12s. Nope. What's positive 12 minus 12? 0. Now that I know they add up to 0, so my negative 4x plus 0 is just going to be negative 4x. Now I can slash it out. So when you're doing those minor calculations in your head as you're writing, and you actually can do that calculation faster than you can write it, that's how you catch your mistakes. So please don't skip that step of showing your work and then actually thinking through each step of the problem. So bring down your negative 4x, bring down your equals. 12 minus 12 is 0. That's correct. Okay, 12 minus 12 is 0. We can have zeros in math. That's going to happen all the time. A lot of the time. So then x is being multiplied by negative 4. We divide by negative 4. The negative divided by a negative is a positive. Negative 4 divided by negative 4 is positive 1. So we have positive 1x equals 0 divided by negative 4 is 0. Okay, solving equations with variables on both sides. So now we need to simplify, and then we also need to combine like terms across the equal sign. So we have x's on both sides, and we actually have numbers on both sides, or we have x's on both sides and numbers on one side. So let's see if I can straighten out this paper a little bit better. Okay, so we have 6x minus 8 equals 5x plus 9. So we want all of our variables together. Okay, I can do this one of 2 ways. I can either subtract 6x from both sides, okay? Or I can subtract 5x from both sides. If I subtract 6x from both sides, I'm gonna end up with a negative 1x over here, which I don't want. I prefer, it will still work though, I prefer to have positive values for my x, so I'm going to subtract 5x from each side. The golden rule of algebra is whatever you do to one side, you have to do to the other. Okay, so on the left side, 6x minus 5x is x. I'm going to bring down my minus 8 equals. Then 5x minus 5x is 0. So 5x's, take away 5x's is 0, and 0 plus 9 is 9. Okay, then I just add 8 to each side. And negative 8 plus 8 is 0. So that slashes out, bring down the equals. 8 plus 9 is 17. Okay, number 2, so this right-hand side only has x's, so I just want to leave my x's over there, leave those there, and get these other x's on the same side. So we're combining like terms, we want all the x's together on the same side of the equal sign. So I'm going to add 4x to each side. This gives me 15 equals 10x. Okay, then I'm going to divide each side by 10. 10 divided by 10 is 1, x equals, now I see 15 and 10. 15 tenths is a fraction. Okay, so I'm going to simplify that fraction. Do you see it there? It's a fraction, guys. 15 tenths. Do not break out your calculator. I mean, you could write 1.5 if you could do that in your head, but this is 3 halves because you're both divisible by 3. So this is 3 halves. X equals 3 halves. In math, when we are doing a calculation with all whole numbers and we end up with a fractional answer, you kind of have a choice as to whether you're going to write your answer as a fraction or a decimal. I prefer you to use fractions as much as possible because we are going to be working a lot with slope and graphing this year. And when we're doing slope and graphing, that's going to help us when we are graphing lines. So really it's good to reinforce your fraction skills all year long. Okay, so the fraction is preferred. If you're given a problem with a decimal, it's expected that your answer will be written in the decimal form. Okay, that's also a notation or just a standard accepted thing in math is keep the format. If you're given something as a decimal, keep it in decimal format. Don't change it to fractions or vice versa. Okay, number 3. Okay. Okay, then on number 3, we have 5 minus 10x equals 10x minus 15. So again, we have x's on both sides of the equal sign. We have to decide where do we want those to be. I can either, if I want to move this one, I can do the opposite of minus 10x. I can add 10x to both sides. And that's what I'm going to do because I want to have positive x's. The other option, which is still a good option, you could subtract 10x from each side. I would have negative 20x. Okay, so we will add 10x to each side. This gives us 5, and then negative 10x plus 10x is 0. So over here we have 10x plus 10x, which is 20x, and then bring down the minus 15. Okay, now it's just a 2-step equation. We do our order of operations in reverse. So we add 15. Okay, and that gives us 20 equals 20x plus 0 because negative 15 plus 15 is 0. And then we divide each side by 20. 20 divided by 20 is 1. Side 1x equals 20 divided by 20 is 1. So x equals 1 or 1 equals x. Okay, number 4, this is a different one. So here I have 8 minus x equals negative x minus 4. Okay, now if I think of this, so if I just imagine this negative 4 being first, okay, if I rearrange the right-hand side of this equal sign, it would read negative 4 minus x. Do you think that 8 minus x can equal negative 4 minus x? No. Okay, they're 2 different statements, right? It's like saying x plus 2 is equal to x plus 3. No, it's not. X plus 2 is equal to x plus 2. Okay, so the same situation here, if you imagine this being rewritten, I'll actually write it here. That's just a random thing to help you with the thinking process. But if you wrote this as 8 minus x, and this as negative 4 minus x. If I'm at 8 and I take away a number, that's going to give me a different value than if I'm at -4 and I take away that same number, okay? Because 8 is here on the number line, -4 is here on the number line. If I take away x from both of them, okay, they're not going to be equal to each other. I just took those two numbers that are not equal and I decrease them both by the same amount. Okay, they're still not equal numbers. Okay, so it's not going to be equal. So that's just if you can think of it. Now, this is, and some of you may not have understood what I just explained, okay, abstractly. Let's look at it algebraically. Okay, so let's do that with the representation of just algebra. Okay, so we'll combine like terms, right? We're going to add x to each side because we want to get all of our variables together on the same side, right? So I have a minus x, I'll add x to each side. 8, what's negative x plus x? 0. So that cancels out. Bring down your equal sign. What's negative x plus x? 0. Bring down your -4. 8 equals -4. No, it doesn't. Okay, 8 does not equal -4. That's not true. So when we have an untrue statement, our answer is actually no real solutions. Okay, this will never be equal. Okay, Taylor Swift could write a song about it. Okay. Let's do some samples together. So remember, first we're going to distribute if possible. I am going to show you a little shortcut, okay? Just as an FYI, if we come across a good problem that we can do that in. Yeah, I think I'll show you an alternative method to the distributive property in number 5, but I don't want you to use it in this unit. It's just an FYI. In this unit, we're really going to practice using the distributive property, but I am going to show you a slightly more efficient method. And the reason we're making you do the distributive property on all of these problems anyway is because sometimes you'll have to use the distributive property, and we really want you to be proficient with it. But I will show you one other method that works sometimes instead of the distributive property. Okay. All right. So number 1, we have 5 times the quantity x minus 5 minus 10 equals 15. So we're going to combine like terms, or excuse me, distributive possible, combine like terms, get all of your variables to one side of the equation, and then solve the remaining 1 or 2 step equation. So simplify and then solve, okay? So we need to get rid of those parentheses first so we can simplify and then solve. So 5 times x is 5x. 5 times minus 5 is minus 25. Bring down the minus 10 equals 15. Okay, so we're still combining, so we distributed. Now we're combining like terms. So bring down the 5x. Minus 25 minus 10 is minus 35, or negative 25 minus 10 is negative 35. Bring down the equals 15. Add 35 to each side. Negative 35 plus 35 is 0. That gives us 5x equals 50. Divide each side by 5 to get x equals 10. Number 2, we're going to distribute the 4. Okay, so 4 times 2x is 8x. 4 times negative 3 or minus 3 is minus 12. Bring down the plus 2x equals 8. Okay, on the left-hand side, I have 8x plus 2x. Those are like terms. That'll be 10x. Bring down the minus 12 equals 8. Okay, we distributed, we combined like terms. All of our x's are together. Now I'm just going to use my order of operations in reverse. Add 12 to each side. This gives us 10x equals 20, and then divide each side by 10. That gives us x equals 2. Okay, number 3, we're distributing 2. So 2 times negative 3x is negative 6x. 2 times negative 4 is minus 8. Bring down the minus x plus 14 equals 41. Okay, so 6x minus 8 minus x plus 14 equals 41. So now we need to so we distributed. Now we want to combine like terms. On the left side, we have negative 6x and minus x, so that's negative 7x. And then we have -8 and +14, which is the same as 14 minus 8, which gives us 6. Then we're going to subtract 6 from each side. This gives us -7x equals 35, and then we divide each side by -7 to get x equals -5. Number 4, we have 5x minus 7 equals 3x plus 2. So we want to get all of our x's together on the same side of the equal sign. This is bigger, so I know it's, if I subtract 3x, I'm still going to end up with a positive value for, or positive coefficient for x. So I'm going to subtract 3x from each side. This gives me 2x minus 7 equals 2. Add. So now I use my order of operations in reverse. I've combined like terms, add 7 to each side. Okay, so this gives us 2x equals 9. Divide each side by 2. Okay, 2 divided by 2 is 1. So then watch what I'm doing here. 9 divided by 2 is, guess what? It's 9 divided by 2. It's 9 halves, okay? We can just leave it like that. We're going to leave it in the fraction form. 9 divided by 2 is 9 halves. Okay. Number 5, we're going to distribute the 2. Actually, I'll pause there for questions. Okay, so on this one, I said I would show you how to do the problem without using the distributive property. So I am going to show you this on one question, just number 5, but I don't want you to do it on the rest of your equations. We are practicing using the distributive property. So on all of your homework questions, you need to use the distributive property. All right, so then we're going to go ahead and combine, like we're going to leave this here. We're not going to distribute. Okay, which is actually the point of the whole lesson, is to practice distributing, but I do want you to know that sometimes there is a faster way. So I'm going to get my A's together. So I'll add 4A, add 4A. This gives me 2 times the quantity A plus 7 equals 10A minus 10. Okay, and then instead of distributing the 2, we can divide the entire expression by 2. Okay, we can only do that when there are parentheses here, and it's just everything would have been multiplied by 2 anyway. So instead of distributing 2, I can factor out the 2 or divide out the 2. And then whatever, as long as whatever I do to one side of the equal sign, I also do to the other. So then I divide everything on that other side by 2. Okay, 2 divided by 2 is 1. This gives me A plus 7 equals 10A divided by 2 is 5A. 10 divided by 2 is 5. So minus, because it was -5. Then we're going to get all of our A's together on one side. That's larger, so I'm going to leave that one there. And I'll subtract A from each side. This gives me 7 equals 5A minus A is 4A minus 5. Then I'll add 5 to each side to get the numbers together. So I have all the A's on the right-hand side. I will want all the numbers on the left-hand side. This gives me 12 equals 4A, and I'm out of space. I'm going to jot that down up here. 12 equals 4A. Divide each side by 4, and we get A equals 3. Okay, so that's just another way if you don't want to distribute. And sometimes we want to avoid distributing, especially if we have some unusual numbers in here or decimals or fractions that don't have a common, that won't cancel out. Okay, so that's just another way. We're not going to do that on the homework. I just wanted to show that to you so you can kind of keep that in mind. Okay, number 6, we're back to distributing. So we will distribute the 2 over the quantity x minus 3. So this will give us 2x minus 6 equals -7 plus 2x. Then we're going to get all of our x's together, okay? We're going to end up with another interesting one here. So I want all the x's together. So when I try to do that, subtract 2x, subtract 2x, I end up with -6 equals -7. -6 does not equal -7, so they're not equal. So there's no real solution here. Okay. Then number 7 is going to, so this is a special case. All right, then number 7. So we have x and 2x on the left-hand side. These are like terms. I want to combine those. So I have 3x, bring down the minus 8 equals. Here we're going to distribute the negative 2 over the quantity 4 plus x. So that equals negative 8 minus 2x, bring down the plus 5x. Okay, we want all of our x's together. We need to combine like terms on the right-hand side before we start crossing the equal sign. So make sure each side is simplified before you start adding and subtracting on both sides. It just makes it faster. 3x minus 8 equals. Then we have 5x and negative 2x, which is the same as 5x minus 2x. So I'll bring down the minus 8. 5x minus 2x is 3x, so plus 3x. Okay, then we have 3x minus 8 is equal to negative 8 plus 3x. These, do you recognize that those are the same? So if I rewrote this one, it would be 3x minus 8. This one is 3x minus 8. They're going to be equal all the time. They're the same number. So let's prove that. So this will be the all real solutions. Okay, or all numbers make this true. And let's see what that looks like algebraically. Okay, when I want to get my x's together, so if I do minus 3x to try to combine like terms, what happens is they both cancel out. And I end up with this, negative 8 equals negative 8. When does negative 8 equal negative 8? Always. Okay, when does negative 8 equal negative 8? Always. So this is always going to be true no matter what value I put in for x. Okay, so x can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be negative 1,500,000. It can be anything, okay, and it'll always be true. So our answer here is all real solutions.